So if you look at all the derivatives we've done thus far, every start has been y equals something, something, something. Y equals x to the fourth plus 3x squared plus something. Y equals sine of x, da 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 da. So every function we've been given has been explicitly solved for y. So this is explicitly solved for y. Now these guys aren't like that. It's not solved for y. How sad. And so what you might say, oh, that's okay. I'll just solve for y and then take it from there and use all the stuff that we were doing before. But easier said than done. Sometimes it's quite difficult to solve for y, like this would not be pretty. And then if you have other functions like polynomials mixing with trig functions, it might even be impossible to solve explicitly for y. So we're going to learn implicit differentiation, where you're just going to have at it and take the derivative of everything right as it is and see how it goes. So we'll just do it. We'll take the derivative of 2x cubed first. We can do that. 6x squared. Then we're going to add the derivative of x squared y. Okay, we have a product, right? We have two functions multiplying together. So I'll use my product rule. I'll take the derivative of the first guy first, and I'll leave the second alone, and then I'll add the reverse. I'll leave the first guy alone and take the derivative of the second. Now what's the derivative of y? Oh, the derivative of y is literally the derivative of y. It is dy dx. So why didn't we do that with the x? Because the derivative of x with respect to x is just 1. X isn't changing with respect to itself, but every time you take a derivative with something with a y, you're going to have to slap this extra dy dx on it. We'll keep going. You'll see. All right, so I think we finished that. This was the derivative of the first, left that guy alone, left that alone, derivative of the second. Cool. Now to keep my negatives straight, I'm going to put a big subtraction sign and then do product rule again. So, product rule again. I've got another product, so my first is x, my second is y cubed. Take the derivative of that first guy, it's just a 1. Leave the second guy be. Then add the reverse. Leave the x alone. Now take the derivative of y cubed. Starts out very normal, 3y squared. But you have to go and take the derivative of the variable itself. So we have to do a little bit of chain rule at the end and multiply by a little dy dx. Just tack on a dy dx. So it's like one little last step of chain rule, taking the derivative of the inside, the derivative of the function itself. And notice again, we didn't have to do it, or we were doing it for these guys, but when you took the derivative of x, it was just a 1. So every time you take a derivative with a y, slap on that little dy dx. And we'll keep going. And then it'll equal the derivative of 2, which is just 0. All right. So, awesome. We want to find the derivative. We've got an equation with a bunch of derivatives in it. We are just going to solve for dy dx now. I'm going to go ahead and distribute this negative. So this will be a negative that, and then this will be a negative that. So that negative got distributed to both. And I'm going to kick everything without a dy dx onto the other side and leave everything with a dy dx on this side. So this guy is staying put. This guy is staying put. I'll rewrite it as 3xy squared dy dx. And then everything without the dy dx gets shoved over, so that's negative 6x squared minus 2xy, that stayed, and then plus y cubed. Cool. So I've got all 1, 2, 3, 4, 5 pieces. 1, 2, 3, 4, 5 pieces. Excellent. And so just normal solving. I've got dy dx in both of these. Go ahead and factor it out. So dy dx times x squared minus 3x y squared, like that, equals this whole mess over here. It doesn't change. Grand finale, just divide both sides by that. So if we divide both sides by that, x squared minus 3xy squared, we get dy dx equals negative 6x squared minus 2xy plus y cubed all over x squared minus 3xy squared. Ta-da! That is your derivative. Kind of a little disappointing, right, that you've got all the y's and stuff in there, so it doesn't, but it's what we can do. And that is that. And then eventually as you do them, you'll be able to kind of swing this part around faster. You'll be able to kind of manipulate it a little bit quicker, but that's the process. All right, and I'll do it again in the next video for that.